disk. So x minus 2 can equal 0. 2x plus 1, move that over a little. Can equal 0. X minus 5 can equal 0. Or 3x plus 2 can equal 0. Because we're looking for 0 equals x minus 2, 2x plus 1, x minus 5, and 3x plus 2. Okay, so that's our x-intercept. So that means that x can equal 2 for that one. For this one, if you subtract 1 then divide by 2, x can equal negative 1/2. For this one, x can equal 5. And for 3x plus 2, if you subtract 2, divide by 3, x can equal negative 2 over 3. There. Now the only difference is when they say find the zeros, you're going to leave it just like that. You're not going to put a specific point. Okay. So for those, you do not write as intercepts. Okay, so you would leave it just like that when they say find the zeros. Okay, any questions on this one? All right. Let's say, for example, we want to find the zeros of the polynomial f of x equals x to the third plus 7x squared minus 9x minus 63. Okay, so every once in a while you might have to go back into your factoring bag of tricks. So for f of x equals x to the third plus 7x squared minus 9x minus 63.
Factor by grouping?
Yep, you can actually just use factor by grouping. Okay, where you know if you factor by grouping, that 3 looks a little bit rough. Kind of clean that up a little. There we go. You get those 4 terms. You kind of make 2 smaller subgroups. And you find the greatest common factor from those. So these 2, yep, we can factor out an x squared, which will leave us with x plus 7. And for these 2, we can actually factor out a negative 9, which would also lead us with x plus 7. So since we have our common binomial, we can go ahead and factor that right out to the front. And anything that's left will go into the other parentheses, which is x squared minus 9.
Can we factor that too? Can we factor it? X plus 3 and x minus 3?
Yep, that's a difference of squares. Okay, so you know your difference of squares. A squared minus b squared is a plus b times a minus b. So that means, if you write that as x squared minus, that 3 should have been on the outside. Square should have been on the outside here. x squared minus 3 squared. That would just be x plus 3 times x minus 3. Okay, so now we know our f of x is equal to x plus 7 times x plus 3 times x minus 3.
-7, -3, and 2.
Yep, so that just means we're looking for the 0. X plus 7, x plus 3, and x minus 3. Our x plus 7 can equal 0. Our x plus 3 equals 0. And our x minus 3 equals 0. So you have -7, -3, and our positive 3. Okay? Remember, you're just going to leave it like that when they ask for the zeros. Okay, so any questions on that one? All right, leave that up for a few seconds. Okay, so now we're going to go through the steps of actually creating a polynomial when you're just given the graph. And we're going to kind of combine everything we've sort of gone over today. Okay, so it's kind of a general form of a factored polynomial. Okay, so that's if you have f of x equals a times x minus x1, and that's to some power. We'll call that exponent p sub 1 times x minus, let's say, some other value. Say that's raised to the power of some number. Say x minus some third value. And we keep on multiplying till we get to x minus x of n to some exponent n. Now, in most cases, those are 1, but not always. Sometimes they're squared, cubed. But we know that p sub whatever it happens to be, we'll call that p sub I, equals the power of the factor. Okay. Now, in some of these problems, they won't call it the power of the factor, they'll call it the multiplicity of the factor. Why? I don't know. I guess it makes them feel smart. Okay, so it's also known as multiplicity of the factor. Okay, so when you see multiplicity of the factor, they just mean the power of that particular factor. Okay, so now we're just going to have the steps to create a function. From a given graph. Okay, so they're going to show us a graph, and we find out the function. We create the function. Okay, so your first step, you want to find your x-intercepts. All remember, those x-intercepts are x1, x2, x3, x4. Because if x equals x, whatever this x1 is, everything becomes 0. If x equals x2, everything becomes 0. So it's always going to be whatever's in those spots. All the way to whatever some x of n is. Okay. So second, you want to determine the power of each function. No, not each function, each factor. Okay. And there are two ways you can determine the power of a particular x-intercept. Okay, so we'll call that 2a. If it crosses through your x-intercept, then you know it's going to be an odd exponent. If the graph crosses the x-axis, the multiplicity of that factor is odd. Okay. Now, if it just touches it or it kind of bounces off of that graph at the x-axis at that point, then you know that exponent is going to be even. So if the graph touches or bounces off the x-axis, the multiplicity of that factor is even. Oh, move that up a little bit. Okay, so your third step, now you're going to find the smallest degree value that would make step 2 true. Find the smallest degree polynomial that would make step 2 true. And your last step will be to solve for a, because we're going to set it up to look just like this. So we'll have everything, all of our x1s, x2, and everything else. Then we'll just have to find our a. And usually the easiest way to do that would be to use the y-intercept. You can use any point, but the y-intercept is just a little easier. Okay, so fourth, solve for a. Using the y-intercept is easiest. Like I said, not the only way, but just the easiest. Okay, and that helps us find the vertical stretching and shrinking. Stretching or shrinking. All right, so I'll leave that up for a few seconds. Bless you. Okay, so one, oops, keep still writing.
Are we going to do some review for the test today?
Oh yeah, we'll be done with these in like 5-10 minutes. Well, we won't do reviews, but if you have questions, you can ask. All right. Oh. Okay, so a quick note, you can actually find the degree of a polynomial by looking at the graph. So the degree is actually equal to the number of turning points plus 1. Okay, so let's say if we wanted to write a formula for that particular graph. I mean, not a formula, a polynomial for that graph. Okay. Now the first thing you want to notice that you have 1, 2, 3 turning points. Okay, so there are 3, I'll just write out the word 3 turning points. So we know the degree will equal the number of turning points plus 1. So the degree is equal to 4. Okay, so we can tell that before we start on anything else. Okay, so remember our first step, find the x-intercepts. Okay, so we know our x-intercept is at -3, 2, and 5. -3, 2, and 5. So this is actually our x1, x2, and x3. Okay, so we're going to start with f of x equals, well, I forgot my a times x minus x1 times x minus x2 times x minus x3. And those exponents p1, p2, and p3. Okay, so we're going to start with that since we already know it's degree 4. We're going to start with those points there. Okay, so the second, we found out whether it crosses or it bounces off each particular intercept point. Okay, so we know it crosses through x equals 3, well, x equals -3. Okay, so we know this particular one is odd degree at -3. Okay, so you notice at 2, it kind of bounces off of it. X equals 2, so we know that's going to be an even degree. Okay, if you look at 5, it crosses 5. So we know that's going to be an odd degree. Okay, so that means we have f of x equals, we still don't know what our a is, so we just leave that as a. Our x minus x1, that would be x minus negative 3, so x plus 3, times x minus x2, that would be x minus 2, times x minus x3, so that would be x minus 5. Okay, so we know it's degree 4. We figured that out right at the very beginning. So if it's degree 4, what's the smallest exponents that will make this true?
2.
Yep, so we can make this 2, this 1, and this 1. So x equals negative 3, that's going to be 1, or you can just leave it like it is. X equals 2, that one's going to be squared. And at x equals 5, that one's 1. So really that's just a times x plus 3 times x minus 2 squared times x minus 5. Okay, so you see here we have our 1, 1, 2, our degree 4. Okay, so we have a big chunk of our formula, but now we have to do step 4, which is solve for a. So we solve for a. And we use our y-intercept for, bring that down some, our y-intercept for that. So our y-intercept is, yep, negative 2, 0, negative 2. Okay, so we know that's 0, negative 2, so that means when x is equal to 0, y is equal to negative 2. When x equals 0, y equals negative 2, or you can say f of x equals negative 2. Okay, so that means we get our f of x equals a times x plus 3 times x minus 2 squared times x minus 5. Replace our x with 0 and our f of x with negative 2. So that gives us negative 2 equals a times 0 plus 3 times 0 minus 2 squared times 0 minus 5. Does that make sense? Okay. So now we have all the other variables gone. We can solve for a. Okay. So that means negative 2. I'll put it next to it, so I can write the final answer underneath it. Okay, so we have negative 2 equals a times 3, negative 2 squared is 4, times negative 5. Oh, that should be, yep, that's positive 3. Okay, so that gives us 12 times 5 is negative 60. So negative 2 equals a times negative 60. Divide both sides by 60. Bless you. You get a equals 1 over 30. Okay, so all you have to do is just replace a in this one, and you have your polynomial. So f of x would equal 1 over 30 times x plus 3 times x minus 2 squared times x minus 5. Okay. So that's the polynomial of the graph. All right. Any questions on that one? All right, we'll do one more quick example. Okay. so this one they actually gave you that it's degree 4. So you didn't have to figure it out, but we see here if it bounced off there, well, it has 1, 2, 3 turning points. 3 plus 1 is 4, so we would have been able to figure that out. Okay, so for this one, first thing you do, we find our x-intercepts. Okay, so we can see here is at -2 and 4. Okay, so that means we're going to start off with our f of x equals a times x minus x1 and x minus x2 to some power. Because remember, you only have 2 points, x1 and x2.
And the degree is 4.
Yep, and the degree is 4. Okay, so that was given to us. Okay, so we go to our second step. We can see it bounces off -2 and bounces off 4. So both of those will be even. Bounces off x equals -2. So that one's an even degree. And it bounces off x equals 4. So we know that's going to be even degree. Okay. So the only way you can have 2 even degrees and have the degree total equal 4 is if both of them are degree 2. Okay, so that's going to give us f of x equals a times x minus -2. Yep, so x plus 2 squared times x minus x2, so x minus 4 squared. Okay, so we have our degree 4, and we have the largest part of our function, our polynomial. So our fourth step, we just solve for a. Yep, so our y-intercept is 0, -4. Okay, so that just means when x equals 0, y is equal to -4. Or f of x is equal to -4. Yep, so we have our -4 equals a times 0 plus 2 squared times 0 minus 4 squared. Okay, so that would be -4 equals 4 times 16. Well, a times 4 times 16, which would be 64. Okay, so that means a would equal 4 over 64, or -116. Okay, so now all you have to do is plug that in there. So f of x is equal to -1 over 16 times x plus 2 squared times x minus 4 squared. Oh, bring that up a little bit. All right, which makes sense because it's a negative lead coefficient. It's going down. It's, if you notice, is going down to the right, down and to the left, similar to -x squared. So you know the exponent is going to be even. So everything kind of matches up. All right. Any questions on this one?